All right, so this problem is going to be easiest to show you. I'm going to have to draw out here. So this is problem 10.3.31. And in a certain city, there are 9 streets going north-south and 5 streets going east-west. And how many street paths start at the southwest corner of the city and then end at the northeast corner and have the shortest possible length? Okay, so this will be the easiest if I just draw out a grid for you and actually show you what's going on. Okay. So we have 9 streets going north-south. So this is going to be, I'm just going to draw 9 streets basically. 5, 6, 7, 8, and then 9. And then we have 5 streets that are going east-west. So it basically creates a grid. If you take a look at this, so we've got 9 this direction, 5 this direction, all right? And our goal is to move from this corner, which is the southwest corner, or let's see, they want to go start at the southwest corner, so that's actually this corner, sorry about that, and then moving to the northeast corner. Okay, so we're trying to move from here up to here. Now, in order to get there, you're going to have to, let's just analyze what's going on here. You're going to actually have to move a total of 4 streets north. So you're going to have to go 1, and then 2, and then 3, and then 4. I should say blocks. So it's going to have to be a total of 4 blocks in the north direction. And then we're going to have to travel a total of 8 blocks east, because it's going to be 1, 2, 3, 4, 5, 6, 7, and 8. So 8 blocks east. Okay. Now what we're looking for, and what I just drew out there, is actually one of the paths to get there. But there are a bunch of other paths. You can go up, over, you know, and so on. And that's what we're trying to count. Okay. So really what it is I'm actually just going to count one or the other of these, because for instance, if I count the number of ways that I can go east out of a total of 12, then the north is already taken into account. It's going to have to happen. So to get from here to here, if I have gone, you know, 8 east, then, you know, the 4 north, there's only one way to do that. Okay, so I only need to count one or the other of these, and I'll show you what I mean here. Okay, so there's a total of 12 streets, and in order to count this, I'm going to use a combination, because the selection doesn't matter how we select these. So it's a combination of 12 things taken 8 at a time would be one way that I could talk about this. So that would actually count the number of ways that I have to go east. From 12 total streets. And then the north is taken into account, because there's really just one way to go north at that point. The other way to count this is I could just count the north, and I could say that's a combination of 12 things taken 4 at a time, and there's again just one way to go east after you've counted all of those. Okay, so you can actually calculate both of these and you're going to get the same answer. This is a symmetrical kind of a problem. So I think I'll just go ahead and calculate this one, combination of 12 taken 8. So I'm going to go ahead and turn this over. Oh, nope. So on a new piece of paper here, a combination of 12 things taken 8 at a time. This is going to be 12 factorial over 8 factorial times 12 minus 8 factorial. Okay, and actually let me just show you, since I'll just show you that these are the same thing. So if I were to calculate a combination of 12 things taken 4 at a time, that would be 12 factorial over 4 factorial times 12 minus 4 factorial. Okay, so I'm going to rewrite it because you can't see it. Okay, so just notice here that if I go and I simplify, you know, over here I get 12 factorial over 8 factorial, and 12 minus 8 is 4 factorial. Here, I get 12 factorial over 4 factorial, and then 12 minus 4 is 8 factorial. And notice that those are the same thing. Okay, so it actually doesn't matter which one you count. You can count either one, and you're going to get the same answer. So I'm just going to go ahead and continue with this one, all right? So I'm going to write the 12 out, 11, 10, 9, down to the position where I get an 8 factorial, so that can cancel with the 8 factorial on the bottom. And then I'm writing the 4 factorial out all the way down. And so then now the 8 factorials cancel, and you can do some more canceling here, or you can just multiply and divide. I'm going to go ahead and just, the 4 and 3 is 12, so I'm going to cancel those. And then I'll just, you know, see what's left here. So I've got 11 times 10 times 9 in the numerator, so that's 990. And then in the bottom, I just see a 2. So if I take that 990 and divide by 2, I get 495 would be the answer there.